Hello everyone, welcome to the class. And today's class we are going to see some more numericals from your electric dipoles. Alright, so this is again numericals from the electrostatic topics. So we will basically see few questions from your subtopics, that is electric dipole. Alright, and my name is Mohana. I'm a physics educator at Unacademy. So basically I'll be taking all of you class 11 and 12 physics. Okay, and this is my Telegram group link. You can follow the channel. So before going live on YouTube, or in case if there's any more special classes that are there on the platform, I'll be sharing the link. Any updates would always be there in my, I'll inform any updates that will be there on my Telegram channel. So you can follow me. This is my personal Telegram channel. At the same time, this is basically for the Unacademy ICSC and ISC board Telegram channel. You can actually follow this one as well. Okay, and just like how we have free classes on the platform, right, like on the YouTube channel, similarly we also have free classes on the Unacademy platform. You can watch these free special classes are absolutely free. You can take any of your favorite educators classes, and we have a special features that's basically pools. So you can engage with your educators via using this pool feature. So in case if you're learning a concept, the questions will be asked in some of the questions that you've learned in that whatever concept you learned, based on this concept, some questions could be asked in the pool format and you can answer. That way you can learn much more. You can check whether you've learned well. Right, so you can engage with your educators via pool. Now, since these are again live special classes, whatever doubts you have, you can get them cleared as well. Okay, so these are if in case you want to access these special classes, you can see the recordings of the electrostatic special classes and also current electricity. And we actually had an IPL series this month. Right, we did a series of classes. Those in the IPL series, we tried to cover descriptive type questions. All right. So if you want to access these classes, you can use my code MTIS10. So you can just go to the Unacademy platform, use this code MTIS10 to access these special classes. Now, also I'll be telling you about these special classes in the upcoming classes. Okay, what special class for class 12 we have in the Unacademy platform. I'll let you know in the coming classes. Now, in case if you want to take a plus Unacademy plus subscriptions, these are the various features. So first of all, these classes are online, so you will be learning from the comfort of your home. Now, you will get unlimited access to all courses, right? And also all the educators on Unacademy platforms are really good, so you'll be learning from top educators. Now, we have a doubt clearing sessions. Okay, so in case if you have any doubts, okay, today if the batch is starting, every fourth class will be a doubt clearing class. So every fourth session of any plus course would be a doubt clearing session. Okay, now we would be covering your syllabus. Complete syllabus coverage would happen in your plus classes, right? And we also have live test series. So every weekend there will be a test series for plus subscriptions students. So you can take this live test series. After the test is over, there would be an analysis session. In case if you have any doubt, you can get your doubt clears during the analysis session as well. Okay, and we are coming up with new batches and courses, so do check out. Next, if you look at the course pricing, the longer duration course you take, the prices per month reduces. Okay, so this is the price for a 12 months course. At the same time, if you're using my educator code MTIS10, you'd be getting a 10% discount on the same. Right, so always try to take the longer the subscription for a longer duration. The price per month reduces. All right. Now, currently, Unacademy has its UNSAT, that is the Unacademy National Scholarship Admission Test. In case if you're preparing for a IIT JEE or NEET UG, and also if you're in case if you're looking for the foundational courses, right? If you're in class 9 and 10, and if you're looking for foundational courses, then the Unacademy UNSAT, right? This basically is a scholarship test, right? this test is a computer based test, but it happens in the offline centers. Okay, this happens across 40 cities, and the date is from June 4th and 5th, and the last date to register is June 2nd. Now if you attend the test, and if you're coming in the top rankers, if you're coming in the top 40 rankers, you have a chance of winning an iPhone. Test takers can also get an Unacademy t-shirt. Now you can win a scholarship depending on your ranking, right? If you're coming in the top ranks, then you can get up to 90% scholarships. Okay, for both, if in case you want to take these courses in Unacademy centers, for that also you'll be getting a scholarship, right? And up to 90%. Okay, so you might be getting the certain amount of percentage scholarship for the complete fees. You don't have to pay the complete fees. There will be a subscription. There will be a scholarship for you. So you can take the scholarship for the course, and that is true for even if you're taking from the Unacademy centers, or even if you're taking an online subscription. Now the course, to take this exam, you have to pay to register. You have to pay a fees about 199 around 199 rupees. But if you're using my code MTIS10, you will get a discount of 10% on that price. All right. Now last class we basically started with what is a dipole, correct? So you can actually go watch those recordings, and today evening also we would be covering. Today evening there is a class at 8 p.m. We will again cover the topics of dipole, but today's class right now while we doing numericals. Now in this class, before we go ahead, let's see the formulas that we need to know. What are the formulas we need to know? So one thing is, you should be knowing what is the electrostatic force between two charges. Alright, so the electrostatic force between two charges is basically given by the constant K. That K is nothing but 1/4 pi epsilon naught, right? Q1, the product of the magnitude of the charges by the square of the distance between them. This equation, right? The force is given in newtons. So this basically gives you the magnitude of the two charges. Yesterday, same timing, we have done a class based on electric field and electric forces numerical. So you can check out the same class. You can check out that class as well. Okay. Now, what is an electric field? Okay. Electric field equation is very simple. Electric field is nothing but force per unit charge. Force per unit charge, right? Now, force per unit charge, this from here we can get the equation of charge as what? You can get the equation of charge of electric field as 1/4 pi epsilon naught, right? Q divided by R square, right? One of the source charge, right? This is the source charge, because if this is F value is Q, Q naught divided by R square, square naught and Q naught get cancelled. Then the unit is basically Newton per Coulomb. Right, and this is also vector quantity. So this is about your electric field. All right, next topic is, then we started with your continuous charge distribution, because continuous charge distribution is nothing but, just imagine this charge is spread in a continuous manner in any given region. Okay, now such a distribution is basically a continuous charge distribution. There were three types. One is volume charge distribution, surface charge distribution, and linear charge distribution. Okay, all of three. Linear charge distribution, so for the linear charge distribution we use this lambda. This is given by charge per unit length. Charge per unit length. So since this is charge per unit length, the formula over here will be Coulomb per meter. In case of volume charge distribution, the surface charge distribution, this is again comes towards the two-dimensional surface. So surface charge distribution in this case is given by sigma. This is again charge per unit area. So what happens to your units? So this will basically be Coulomb, right? Unit area. So this will be meter square. Coulomb per meter square. Okay. Next. A volume charge distribution is a three-dimensional space, volume of space, right? So that lambda, right? Sorry, this is given not by lambda. This is basically given by rho. The rho is basically equal to charge, right? In this case, it is equal to charge by what is the volume of space, right? So this is given by per unit volume, charge per unit volume, right? And the unit is basically coulombs per meter cube. Though this is charge per unit volume. Okay, next. We also learned about electric lines of forces. The electric lines of forces are very simple, right? What is the force if you keep a unit positive charge, right? If there's an electric field and if you keep a unit to positive charge, the force in which the direction in which the force acting on that positive charge, right? If you draw a line, okay, then that gives you the electric lines of forces. So electric lines of forces are imaginary lines, but at any point on this electric lines of forces, if you draw a vector, right, if you draw a tangential curve, that gives you, at this point, if this is my electric lines of force, at this point, if I'm drawing a vector, this gives you the tangential, okay, if you tangential to this, at any point, tangential to that gives you the electric lines of force. If you draw a tangent, then at that point, you get the electric field. Okay, now, the electric field lines for a positive charge is always pointed radially outwards. They start at the charge and they end at infinity. Okay, so in the straight line. Now, similarly, this has a spherical symmetry. Anywhere you look from, it will look the same. Similar to this, the electric field lines of a negative charge also follows a spherical symmetry. But one thing is, for this, the field line starts at infinity and ends in the charge. So the field lines, electric field lines, are pointed radially inwards. Okay, now what happens if you bring one positive charge and a negative charge close to each other? Now the electric field lines will always start at the positive charge and end at infinity, right? At the same time, for a negative charge, it starts at infinity and ends in the charge. The field lines will actually bend, so it will start at the positive charge and end inside the negative charge. Okay, so now it ends at the negative charge. Now, depending on the charge over here, the electric field lines, the positive and negative charge, they would start and end. If it's like charges, then what you will see is basically a repulsion. Okay, so these we have covered in the last class. You can actually check these out, right? Now, the next concept we came up with was basically what is an electric potential, right? Dipole potential, right? Electric dipole. So electric dipoles are nothing but the two equal and opposite charges. If they are separated by a small distance, they constitute an electric dipole. So I have two charges and they are separated by a distance. Okay. Now, what should we do? The magnitude of both the charges has to be same. The magnitude of both the charges has to be same. So if this is minus 2 microcoulomb, this has to be plus 2 microcoulombs. Meaning how much of our electric lines of forces are coming out from the positive charge will end in the negative charge. So here the charge direction is always from positive to negative, right? So all the lines from the positive charges will end in the negative charge. All of the lines from the positive charges will always end in the negative charge. Sorry about that. Let me just erase that. Alright. So this is about your electric dipole. Now the electric dipoles are very interesting phenomenon to study simply because they exist in nature, right? Your water molecule, if you look at the water molecule, right, you have two hydrogens and one oxygen. No, the oxygen and the hydrogen, there's a small gap between them. Their center of masses, no, they don't collide. Okay, there's a small shift in their mass. Okay, because of that, because there's a small shift between them. Okay, now because of that becomes an electric dipole. Okay, now electric dipoles do exist in nature, and studying these dipoles, properties of these dipoles, helps us understand about those molecules. Okay, now this gives you an electric dipole. Now the next concept you need to see is what is an electric dipole moment. The electric dipole moment is very simple. It just gives you the strength of your electric dipole. Okay, and this is a vector quantity. Why? Because over here, what is the distance? If you take two charges and you separate them by a distance from the center to the midpoint, let's say this distance is A. From this point to this here, the distance is A. Then you can say the distance between them is basically 2A. If you take two charges, they have equal magnitude and they are separated by a distance. So this is basically an electric dipole. Okay, now this electric dipole, this A, this is a position vector. No, the distance between them is a position vector. So because of this, though Q is a scalar quantity, A is actually a vector quantity. So from here we can say the dipole moment is a vector quantity. Why? The dipole moment is nothing but the product of either one of the charge, any one of the charge, the magnitude of any one of the charge. You can take the magnitude of any one of the charge. Okay, so that is Q, okay, times the separation between the two charges. What is the separation between the two charges? You can take it as D. In most books they will take it as 2A. Okay, from the center to this center is A, from the center to this center, from this point to this center is A, from this point to this center is again A. Overall the total distance is 2A or 2L. They also take it as 2L. Okay, so the separation distance between them, so that is again 2A. Okay, now the direction, this basically gives you dielectric dipole moment. The electric dipole moment just measures the strength of an electric dipole, and it's a product of charge times the separation between them. So, and it's a vector quantity. So it's a vector, it should have a direction, right? So the direction is always from negative to positive charge. The direction of the dipole moment is always from negative to positive. Okay, that's it about your electric dipole. Now, in such a case, right, if you see, the field lines is no longer radial and they are bending. Okay, in such a case, the field line at this point over here, the strength of the field line at this point over here is if you're taking, you draw a line passing through the center of the two charges, right? Passing through the center of these two charges, if you draw a line, okay, that is basically the axis of the charges, or the end-on position we say. Okay, on the axial line is the line joining the two dipoles. Okay, on the axial line, if you're finding what is the electric field, the electric field strength on the axial is basically becomes the electric field strength, right, on the axial. That is somewhere over here. This is E axial. So E axial is nothing but 1 by 4 pi epsilon naught axial position. So in an axial position you will get 2p, this gives you the dipole moment, by r cube into the p vector. Okay, that's on the axial. Anywhere on this line, if you're taking the axial is anywhere on this line, if you take this would be your this would basically be your electric field strength. When compared to the radial field, right, when compared to the radial field, if you took the radial field, then you saw that the charge was basically around right. If you see, the radial field just had just had a field by around, in this case, anywhere on this point, if you're taking, right, anywhere on this point, if you're watching, okay, what is my field over here? Anywhere you're taking the electric field lines, it will just be 1 by 4 pi epsilon naught q divided by r square. Okay, similarly for the negative case also, here also you'll get the same value, 1 divided by 4 pi epsilon naught, in this case negative charge, so minus q, right, that minus is just to indicate that it is a negative charge. Okay, r square. This is for a radial field when the lines are straight, but when the lines are when the lines bend, when you have a dipole, okay, when the charges are equal and opposite, when you have a dipole, now the electric field strength changes, right? At the axial means this point joining them, that point, the E axial, okay, becomes 1 by 4 pi epsilon naught, okay, 2p divided by r cube. Now once the dipole comes into the picture, the field line is proportional. Here E is proportional to 1 by r square. But once the field line came into picture, in this case E is basically proportional to 1 by r cube. Now if somewhere on this line, on the center, if I'm just drawing a plane, okay, somewhere on the center, if I'm just drawing a plane at this point, or somewhere over here, okay, in this case I'm choosing the center, but somewhere on this line, these lines, okay, so draw a plane. On the plane, if you want to find at these points, which is perpendicular to the distance between the charges, on these points, if you want to find what is my electric field line, then you can see that the electric field lines in this case, okay, this E will be equal to 1 by 4 pi epsilon naught, okay, P, this will be P divided by R cube into P cap. This is for your unit vector, okay. So from here you can see this is the strength at these points on the line perpendicular field. Okay, so here you get the field as, on the perpendicular field, you're basically getting the field as, this is basically equatorial plane or a broadside on position. Okay, you're getting 1 by 4 pi epsilon naught somewhere over here. Okay, P divided by R cube into P vector. In both cases, you're able to see E is proportional to 1 by R cube. So as you keep going further away, the electric field intensity, right, drops much more further, because this is reducing by R cube. When compared to a radial field, in case of a dipole, the electric field is reducing much more faster. The electric field strength, as you keep going further away, it reduces much more faster. Now, based on these two, we can actually see, okay, from here we can say the equatorial, okay, the equatorial, right, whatever is on my equatorial plane, right, this is basically equal to the E axial. In this case, let's not take the equatorial, right? Okay, if you see, the E axial is basically twice your the electric field lines on your equatorial. So electric field lines on your, in the strength of the electric field lines over here on the axial, right, it's twice the electric field line, except this entire equation over here, right, this entire equation over here becomes equatorial, is equal to equatorial, right? You can write it as 2 into electric field intensity at the equatorial. Okay, so in case of a very short dipole, the electric field intensity, okay, at a distance r along its axis, along this particular axis, is twice the electric field at the same distance. If you're taking from here a distance r, okay, whatever this electric field intensity at this point is, this is basically twice the electric field intensity. In case if you're taking the same r over here, okay, then this particular place where you got the electric field, right, that is always less than what is the field you got here. It's just half of what is the field you got here. So from here I'm drawing a distance at a particular r, I'm taking what is the electric field line. Same distance from the center, I'm taking a particular line r, and on the equatorial or the axial, if I'm seeing, that electric field lines over here is twice this value we found over here. Okay, Deepak, hi Deepak. Okay, so that's the properties of that. This is the equation connecting. Now that we've seen all of the equations, okay, so let's solve some questions. The first question, so all of the questions that you're seeing today, I've taken from your Newton physics. Okay, so this is where I've taken my today's all of the problem questions are taken from here. Okay, so let's try and attempt a question. I hope whatever equations I gave, everything is clear. Okay, now we have 2-point charges, right? We have 2-point charges of charge 100 microcoulomb and minus 100 microcoulomb are kept 2 into 10 to the power of minus 3 meters apart. Okay, so let's do that. So we have 2 charges over here, and these 2 charges are basically, one is a negative charge, this is minus 100 microcoulomb, and another is basically plus 100 microcoulomb. Same charges, opposite, but Deepak, my Hindi is not really good. I am not a native in the Hindi speaker, so how about I speak in English slowly? Would that help? If you have any doubt, you can ask me in the chat box, like in case if you did not understand, I will repeat what I said. Would that work? Okay, alright, I'm going slow. Tell me if this speed is okay for you, right? So this charge over here, okay, this charge over here is negative 100 microcoulomb, right? This means it's a negative charge. This is a positive charge. You have 2 charges, magnitude is same. See, this is 100 microcoulomb, this is also 100 microcoulomb. But one is a negative charge, another is a positive charge. Then what you have is a dipole. Okay, now the separation from the center of this dipole to this dipole, this separation, okay, from here to here, this separation is given by, R, and that R is basically equal to, this separation is basically given by R, right, and this R is equal to 2 into 10 to the power of minus 3 meters. Okay. Alright. From here, first question that we are going to answer for this is, what is the dipole moment of an electric dipole? Okay. Here there is an electric dipole that is formed. What is the dipole moment? Can any of you tell me the formula for dipole moment? Dipole moment. We use dipole moment to give by P. Can any of you tell me what is the formula for dipole moment? Would it be 0? 0, the total charge is, if you take into picture, the total charge is 0. Because one is plus 100 microcoulomb and another is minus 100 microcoulomb. So they are new. So the charges maybe, if you're thinking of, but still it also has a field around them. Net charge maybe you can say, but what is the formula for the electric dipole moment? So electric dipole moment is given by charge times the charge times the separation between them. Okay, then this separation, let's not take it as this, let me take it as 2 into L. Okay, that is from this point to this point, this length is L, from to this half point. Okay, so from this point to this point, this length is L, from this point to this point, this length is L. Or your notebooks will take it as A also. Okay, this is L, this is L. Total length will be 2L. 2L is given as 2 into 10 to the power of minus 3A. So Deepak, dipole moment is given as charge times this distance of separation between them. What is charge? Magnitude of any one of the charge. Magnitude of any one of the charges over here is Q times what is the distance between them. Okay, it is given by what is the distance between them. The distance between them is basically 2L, right? The distance between them is given as 2L. So what is the charge here? The charge, magnitude of the charge is basically 100. Okay, micro, 100. This is charge Q over here is given as 100 microcoulomb. Micro is nothing but 100 into 10 to the power of minus 6 coulomb. So this is 100 into 10 to the power of minus 6. And this distance 2L is basically given as, this is the distance of separation between them. That is given as 2 into 10 to the power of minus 3 meters. So this into 2 into 10 to the power of minus 3 meters. Okay. From here, what will be the dipole moment? From here, if you solve this, you will get the dipole moment as, this will be 2 into 10, 100 you can write as 10 square, right? You will have 10 square, 10 to the power of minus 6, 10 to the power of minus 3. So this entire thing, minus 3, minus 9 plus 2, right? That will become minus 7. So this entire thing becomes minus 7. What will be the unit? What will be the unit of the dipole moment? Unit of dipole moment. One is charge. Charge is given as coulomb. And then the length. Length is given as meter. Coulomb meter. Clear? Any doubts? Any doubt about question number 1? You can actually ask me in the coulomb meter. That's right, Deepak. Right. Any doubts you can ask me in the chat box. Okay. So this is the first question we solved based on dipole moment. Okay. So let's move on. Okay. Second question is same charges, right? One is plus 100 microcoulombs, right? Another is sorry, this is minus. Okay. This is basically minus 100 microcoulombs. This is plus 100 microcoulombs. The separation length between them is what? 2L, which is 2.0 into 10 to the power of minus 3 meters. This is given. Okay. Knowing this, we want to find what will be the electric field. Okay. At 0.5 meters from the center of the dipole in the end on position and the broadside on position. End on position. Position means this is something that is in the in this direction. Okay, that this is in the axial direction. That is, end on position is if in case you draw a line between the two charges, right, and if you extend the line, okay, and if you extend the line, this line, that is the line passing through the two dipoles, okay, the line that passes through the line that passes through the two dipoles, okay, that is your end-on position. So this end-on position is also called as your axial position. Okay, now they are asking us to find what is the electric field intensity on the axial position. Okay, the electric field intensity on the axial position at what point? Okay, from the center of this dipole, from the center of the dipole, okay, from the center of this dipole over here, if I am going 0.5 meters, right, if I am going 0.5 meters from the center of the dipole, somewhere this side or this side, if I am going 0.5 meters, okay, then in such a case they want to find out what is the from here to here, right, from here, okay, this is from the center to this. So this entire distance that we are seeing over here is basically 0.5 meters. According to the question, they are saying this is this entire distance we are seeing is basically 0.5 meters. This length is given to us in the question. This is basically your 100 microcoulomb charge. Okay, till now the question is given. Okay, now we have to find for the end-on position. That is given by what? This end-on position equation is given by 1 by 4 pi epsilon naught. Magnitude only we are going to find. Okay, this 1 by 4 pi epsilon naught. Okay, now 2p axial point, the equation is twice the dipole moment, right? Actually the axial field equation will be twice that of the equatorial plane. Okay, so at this point this is 2p divided by r cube, that is the equation. So we just have to substitute for this. 1 by 4 pi epsilon naught. What is the value for 1 by 4 by epsilon naught? Deepak, my name is Mohana. 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. Right, that is 1 by 4 pi epsilon naught into 2, right, into what is the dipole moment? How do we give dipole moment to? Did we find the dipole moment for this system? We found the dipole moment, right? In the previous question, we found the dipole moment, right, to be 2 into this was the dipole moment value we found, right? We can substitute over here. Dipole moment is basically in this case 2 into 10 to the power of minus 7, right, the whole, right, all of this value divided by r cube. What is the value of r cube over here? R cube, r from the center of the dipole to the point. At this point we want the distance, right? So that will be 0.5 the whole cube. Okay, so in this case, if you solve for this equation, you will get 4, right? This is 4 nines are, and that divided by 0.5 cube. So the answer for equatorial plane, so the answer for the axial point, right, axial line over here, you will find the answer to be 2.88 into 10 to the power of 6. In this case, this electric field line in your unit is what? Electric field line is force experienced per charge. The unit is Newton per coulomb. Okay, now this is the strength at this point over here. I hope no doubts till now. Now let's carry on with the question. Now the question says, according to the question, now they are asking us to find, okay, what is the same electric field, okay, if you are choosing 0.5 meters apart for a broadside on, okay. So this is your end-on position. End-on position is your axial position, okay. Now with the end-on position will be the equatorial plane. In this case it will be 2 up, okay. Now Now the direction of the electric field in this case, in the first case we saw, the direction of the electric field is always along the direction of the dipole moment. The dipole moment is in this direction, so the electric field lines, right, the electric field line, okay, will also be in this direction for the axial. Okay, now we'll find out for the the broadside on position. It's very simple. Right, in this case we have two charges. This is a negative charge, minus 100 coulomb, right, separated by a distance. Have a positive charge, right, this is plus 100 coulombs. Now this place, when we got E axial, right. Now what do they are asking us to find? And the broadside on actually means this point over here. Okay, from here if I go 0.5 meters up, from the center if I go 0.5 meters, so this distance over here is basically 0.5 meters. If I go this distance 0.5 meters, what is my electric field at this point? This is basically your E equatorial. Okay, for a broadside on position, we have seen this earlier, E equatorial is always twice the strength. The electric field lines at the equatorial is always twice, sorry, not twice, it's always half, because as we saw earlier, the axial on the axial, that is at somewhere around this point, if I'm taking this as being the midpoint over here, if this is 0.5 meters, okay, this point over here gives you axial, right? Your E axial is always twice the electric field line strength at the equatorial. Whatever is the electric field line strength at this axial is twice this value, okay, for the same distance r. So E, from here, if you want to find out E equatorial will be what? Half the strength of the axial. We know what is the strength on the axial line, right? We just calculated that. That was basically 2.8, right? 88 into 10 to the power of 6 Newton per coulomb. So if you divide this, right, if you divide this by 2, so then you will get the equatorial value to be half of this value is what? 1.44 into 10 to the power of 6 Newton per coulomb. So at this point the electric field lines are around 2.88 into 10 to the power of 6. This is the strength of electric field lines, Newton per coulomb. But at this point, on this point, because of the short dipole over here, you get the equatorial at this point will basically be 1.44 into 10 to the power of 6 Newton per coulomb. Alright, that's it. So the second equation, we have found this, right? E axial we found, E equatorial also we found. Now let's move on to the third question. The third question, right, the third question now is basically based on now two charges, similar system, two charges of 100 coulombs and minus 100 coulombs, same question. Okay, these are kept 0.2 centimeters 2 into 10 to the power of minus 3 meters apart. Now same system, if you take the same system what we calculated, right, initially what we calculated the dipole strength, we calculated its axial and equatorial, what is the field line like. Now for the same one, if this electric dipole, if you're placing it at a uniform electric field, okay, and if it is rotated by 60 degrees, now we have to find the direction of the field, then calculate the moment of force acting on the dipole. Okay, let's do that. The first thing is, let's say this is my uniform external field means Shinmay, let me just, I'm not very good in Hindi. So are you asking me when is the 11th session, 11th class? We have a YouTube session today evening at 4 p.m. Okay. Okay, so if you have a uniform electric field line, means you're welcome, Chinmay. So in this case, all the direction of the electric field lines are towards one side. Okay, in such a system, if you take this previous cases, right, no problem, Chinmay. So in such a cases, if you're taking the previous case, that is, if you take this dipole, right, if I'm taking a dipole, this is the negative charge, right, negative charge. So this is around minus 100 microcoulombs, and again it has a positive charge as well, right, it has a positive charge. This is again plus 100 microcoulomb, right, and this is the distance between them. It is again given the distance between separation between them, that distance 2L, right, the separation between them, the 2L is given as 2 into 10 to the power of minus 3 meters. All of this value is actually given. Now knowing this, now what they find, now when you keep this dipole in a uniform electric field, what happens, there is an angle the dipole makes with the field itself, right? So that angle over here is basically given as theta, which is basically given as 60 degrees over here. In the question they gave that angle is basically 60 degrees. Okay, now knowing this, what will be the, in which way we have to first calculate the direction of the field, okay, and then calculate the moment of force acting on them. Okay, all right, in this case the moment of force acting on the moment of force is nothing but, now you have one dipole, okay, and you're keeping it in an electric field. Okay, electric field line in this point, what happens, will experience a force in this place. The electric field lines will experience a force in this direction. Okay, this side, this charge will experience a force in this direction. Okay, on the same dipole there are charges acting on two different directions. Okay, what will happen, same force, magnitude of the force is same, but the direction it is acting is on different, and it's acting on the same object, then it will constitute a couple. Obviously this dipole will turn. Okay, now which direction it will turn, it will always try to, now that depends on the electric field line. Okay, electric dipole, whatever is the electric field dipole moment here. Okay, if the electric dipole moment is going, always goes from negative to positive charge, it's in this direction, electric dipole moment will always want to align itself with the electric field. So here the dipole starts rotating, right, the dipole starts rotating in this direction. Okay, as it rotates, as it rotates, because of the force what it experiences in an when you keep an electric dipole in an external uniform magnetic field, it will experience a torque. Okay, that equation of torque, okay, torque on the dipole, that equation of torque on the dipole is given by we just want to find the magnitude, right? In this case it is given by P into the strength of electric field into sine theta. Today evening class we would actually derive the equation in, so you can today 8 o'clock we would be again doing the question on electric dipoles. You can join the class, we will again see the derivation for the same. Okay, PE sine theta. Now what is the dipole moment? Dipole moment we found in the previous question was basically 2 into 10 to the power of minus 7 electric field. Okay, now what is the uniform electric field? Over here the question is given, the uniform electric field of this is your E value is actually given in the question itself. So from here you can actually write E is equal to, this E value is equal to 1 into 10 to the power of 6 into, what is the next value you have? Next is sine. Sine over here is given as 60 degrees. Sine theta, theta is given in the question, this is theta, right? Sine theta is given as 60 degrees. So from here if you calculate 2 into sine theta, right? So if you calculate for this sine theta and the values 10 to the power of minus 7 into 10 to the power of 6 becomes 10 power minus 7. So the final answer you will get, the torque experienced on the dipole when kept in a uniform magnetic field will be 0.1732 Newton torque, right? It's basically given by force times how much displacement, how much it is getting displaced, right? Force times how much it is moving, right? Force times distance. So Newton meter, that will be the force. This is the force acting on the dipole kept in a uniform magnetic field. Why is it important to study? Your microwave oven makes use of this technology to heat food. In the food we have water molecules. Water molecules are permanent dipoles, right? In the micro oven, if I change the electric field line direction, because however these dipole moments are oriented, they will actually start rotating to align itself from the electric field. Now, as it keeps rotating, what happens? That rotation, actually, the rotational motion again of this dipole that is kept in a varying electric field actually ends up heating the food. Okay, so this is your second part of the question. Now, third part of the question, the fourth part. Okay, here they are asking the same system. Okay, how much additional rotation must be given for the torque to acquire maximum value, and what is that maximum value? Now, in this system, what is the maximum value theta can take? That's the question. Okay, in this entire system that we are seeing over here, the maximum value theta can take depends on sine. So, what is the maximum value sine theta can take? It can take 90. That is when it will become 1. Okay, from this equation over here, tau is equal to PE sine theta. If your theta becomes 90 degrees, right, then you have tau PE, this becomes sine 90 degrees. If this becomes sine 90 is 1, then what we get is a maximum torque. Meaning, if you have electric field lines, okay, if your dipole is aligned negative to positive, if they are aligned in this straight way, then the angle this dipole makes with this electric field lines, if it is 90, then this dipole moment has to completely rotate itself to align itself with the electric field lines, right? This is the external electric field lines given. The dipole has to completely rotate to align itself with the electric field line, right? So in this case, okay, so in this case over here, we can see that the theta being 90 degrees is when you will get maximum dipole. Okay, so right, so from here we can say that for maximum dipole, theta has to be 90 degrees. For maximum dipole, theta has to be 90 degrees. Okay, if theta is 90 degrees, therefore the dipole must have an additional. Now here, what are we saying? For this entire system, if it should have a maximum torque, what will be the maximum torque? Then theta has to be 90. Already we are saying this theta is at 60 degrees, right? That is the angle that the dipole is making with the external field. Now this is at 60 degrees. Now if you want 90, right? Then the additional rotation, then it will be, then over here, for it, the torque to acquire maximum, what is the additional rotation? The addition rotation, if you want to find additional rotation, for additional rotation, if you want to find, we already know 60 degrees is there. Okay, maximum torque is 90 degrees. So 90 degrees minus 60 degrees, 30 degrees. Okay, so the dipole must be given additional 30 degrees rotation. Okay, so the dipole must be given must have an additional rotation of 30 degrees for the entire system, for the torque experienced by the dipole to have a maximum value. Okay, what will be the torque experienced? What will be the torque tau max? Let's calculate what is tau max in this case. Right, what will be the maximum torque in this case? If sine 90 is equal to 1, then you will have the dipole moment into the electric field. What is the dipole moment? Dipole moment is given by, we calculated for this entire system, we calculated the dipole moment to be 2 into 10 to the power of minus 7. This times into what is the electric field. External electric field is already given in the question, 1 into 10 to the power of 6. Right, external electric field is given as 1 into 10 to the power of 6. Right, from here, maximum torque experienced will be what? 0.20 Newton meter. That's the maximum torque experienced. Okay, so anywhere, any doubts? Again, you can ask in the comment section, or you can join in the Telegram channel and also ask your doubts. So I hope there is no doubt with this question. Okay, let's have 7 minutes. Let's do one more question, quick question, and then we will end the session. Now we have 3 charges, minus q, plus q, minus 2q and plus q. They are located on the vertices of an equilateral triangle of side 2L. Okay. Now, knowing this, what is the equivalent dipole moment of the arrangement? Okay. So, equilateral triangle. So, according to that, there is one charge here, there is one charge here. Okay. And they are saying there is another charge over here. Okay. So, let this charge over here be positive q. Another charge is another positive q. Let the charge over here be minus 2q. So, you have a minus q and minus q. Minus 2q. Total charge over here is minus 2q. Okay. So, these are the charges. They are sitting on the vertices of an equilateral triangle. Okay. Now, the dipole moment. What will be the direction of the dipole moment? The direction of the dipole moment is always from the negative to the positive charge. In this case, this is a negative charge. Now, the direction of the dipole moment is always from the negative to the positive charge. Okay. Now, from this entire arrangement, we know that, okay, this length is also given. This length is basically the triangle of one side is basically 2L. This length is basically 2L. This side is also 2L. That's actually given in the question. Now, we have to find the equivalent moment of the dipole. Okay. The magnitude, so if you want to find the resultant magnitude of both the dipole is what we want to find. How do we do that? Here we have if you want to find the equivalent dipole for it, we have to find the magnitude. Okay, the resultant magnitude, right? This is a vector quantity and this is going in two different directions, right? So we have to find a resultant for it. The resultant for it, how will be, if I resolve this vector, it will have one vector will go in this direction. For this vector, one will go in this direction, right? For this vector, if I'm doing, so this will be the p sine theta, and this will be the p cos theta, cos theta component, right? Now again, for this one, what will happen? Again, I'll have two charges, right? One, again, this vector, if I'm resolving, one vector will go in this side. This will be for this, let's say this is p1. Okay, let's say this is p1. Let's say this vector is p1. So this is basically p2. Okay, for p2 we have two. One is in this direction, which is p2 sine theta, and let's say this another will be in this direction, which is again p2 cos theta. Sine theta component cancels. What we will have? We will only have the cos theta components. Okay, so only this component, the resultant, will act only along the cos theta in this direction, which is basically in this direction over here. Okay, now what will be the angle? The angle over here, equilateral triangle, all sides are going to form 60, complete, the total sides, right, or everywhere you're going to get 60 degrees, right? So 60, 60, 60, this side is also 60 because the total angle, if you say, will be 180. So this angle over here is going to be 30 degrees and this angle is going to be 30 degrees. Why? 30 degrees and 30 degrees you will get 60, right? So this angle over here is 30 and this angle over here is 30 degrees. Okay, so knowing this, if I want to find the equivalent dipole, my equivalent dipole, okay, P will be because of P1, because of the dipole, this side that is going, that is P1, and this side that is going, that is P2. What is the resultant of them? The resultant of them is given by P1, right? P1 cos theta, that is one component, and another component is P1, P2 cos theta. Okay. From the question, they told us, they have actually told us that P1 and P2 has a length, right? As a length, this is basically 2L. Okay. Now, the length of these two sides, the length, P1 and P2, this is the length. That, that's not just 2L, that is basically the, let me write this better over here. Okay. Now P1 and P2 is equal to what? What is the charge? Magnitude of one of the charges, that is Q, into the distance between them. The distance between them in this case is 2L according to the question. In this case is also 2L according to this question. 2L is given, right? So in this case 2L is given into 2L and both of it is same. Right, P1 and P2, that distance is actually given in the question itself, right? Then in this case, if you're substituting for P, right, this P value will be what? This P value will be what? P1 is what? P1 is 2L, right, Q into 2L into cos theta, cos of 30 degrees, okay, plus this entire thing, plus what is P2? P2 is again Q into 2L into cos 30 degrees, okay. And we solve this in the next page. So P would be equal to, okay, we have 2QL, right, cos 30 degrees, right, and same thing, right, again 2QL into cos 30 degrees. So that's somewhere around 4. So this will basically give you 4QL. So totally you will get 4L into Q, right, anything, into cos 30 degrees. You solve for this, 4 into cos 30 degrees. 4 into cos 30 degrees, if you solve for that, you will get 2 root 3 Q into L. This is the equivalent dipole moment of the arrangement, of this particular arrangement over here. The equivalent dipole moment is basically this one. Okay, right. So we are coming towards the end of the class. Once again, if you have any doubts, you can ask me in the chat box, right? Or you can contact me through the Telegram group. So we are coming up with batches, new batches for the class 12. Okay. Now the class 12 achievers batch. This is an upcoming batch that will start on June 1st. Okay, and the mode of delivery will be in English. The physics I would be taking, and I'll be teaching between 5:15 to 6:15 every Monday, Wednesday, Friday. Math, Jyoti ma'am will take. Chemistry, Manisha ma'am will take. And biology, Lakshay sir would be taking. Okay, the course would be taught in English. Now, UNSAT is going on basically this is Unacademy's National Scholarship Admission Test. In case if you're using any, if in case you're preparing for IIT JEE, NEET UG, okay, or if you're looking for foundational courses, IIT JEE, foundation courses, if you're in class 9 and 10, and if you're looking for foundational courses, now these classes are, you can appear for this test because you can get scholarship up to 90%, both for studying for these courses through Unacademy centers or online subscriptions. You can take, you can avail, if you're coming in the top ranks, you can avail up to 90% scholarships. The you top 40 rankers will win iPhone, and the test takers will actually get the Unacademy t-shirts also. All right, and also the test is an offline test, but it happens in the Unacademy centers. Okay, the last date for registration is June 2nd, and its test will be conducted on June 4th and 5th. Right, and the test, if you're registering for the test, you will have to pay around 199 rupees. Right, if you're using my code MTIS10, you'll be getting a 10% discount on the same. Okay, also for this classes, also for any plus subscription, if you're taking, if you're using my code MTIS10, you will be getting a 10% discount on the same. All right, with that note, we're coming towards the end of the class. Again, Unacademy has come up with a community feature. This is, if you follow, you can follow any of your favorite educators community. Okay, also I've given the link to my community. So in the community, before the educators will always update any update. It's there, it will be there on the educator community, so you can follow them for the same. You can also share your feedback directly with educators. Okay, and Bucks Bounty is in case if at all you come across any inappropriate content in the video, and if you report the shame, right, if you report that issue, then you can claim a prize. Now also like and share the like and share the class video, right, and also click on the bell icon to subscribe to the channel, so that you can stay tuned to the next upcoming classes. The next class is again at 8 o'clock today. We will be discussing electric dipole, right, and torque experienced by an electric dipole in a uniform electric field. So you can actually check out that class. So click on the bell icons to subscribe to the channel. All right. So we are coming to the end of the class, and I hope to see you in the next class. Thank you.